This video is on conditional probability. This was the first examples that we did. We're going to now go on our notes from this first page over to here. And then the next one we're going to go to this third page. And then we'll go finally to this last page. So focusing on this conditional probability. What conditional probability is probability that an event B will occur given that another event A has already occurred. It's that given that symbol, just like without replacement. So event B is dependent on event A. So we would say, what's the probability of that second event given that the first event has already happened? So probability of B given A has already happened. So in order to do the probability of this, because it says given that, the order is really important. In order to figure out for your fraction, the intersection of them together is your numerator. The numerator is the two parts together. Your denominator was that first event. So we would write out our fraction. The probability is going to be event B intersect event A divided by the event A. So we're going to do some examples of this. I'm going to this next page. So again, I'm following this one down to here. This is actually the exact same chart as the first one. So we still need our totals. I'm going to go in and write out our totals again from the beginning part. So the first total of two-year colleges was 4328, then 9841, 3303. Our total was 17472. Our males was 7539, and our females were 9933. Now the conditional probability, just remember it's the intersection of them divided by your given that. So for our first one, we want the probability that a female was chosen given that it was a grad school student. So we have to make sure we know where they overlap. So we want the probability of female intersect grad school divided by our grad school. Because we want to know the probability that it was a female student, but it had to have been a grad school student as well. So female and grad school, so we want the intersection of female and grad school. So that's 1954. 1,954 students out of, we want the total of all grad schools, graduate students. So 3303 would be our denominator. We plug that into our calculator, round to the to three significant figures. We get roughly 0.592. So of all the grad students that were chosen, over half of them were females. So we're going to do the same thing for the probability of a male given the four-year college. So we want to pick a male out of the four-year colleges. So again, this will be, we want male intersect the 4-year divided by the 4-year. So we want the overlap of the male, so males, 4-year colleges. So 4324. Divided by, we want just the 4-year colleges. So go to the 4-year colleges and we want the total of the 4-year colleges. That was 9841. We plug this in, go to three significant figures, we get 0.439. So of the 4-year colleges, less than half of them were males. This last one right here says we want to pick a 2-year college student, but it had to be from the female pool. So we want the 2-year colleges, so 2-year, intersect, we want the female, but we have to take it from the female pool. So 2-year colleges and females. That's 2, 4, 6, 2. 2, 4, 6, 2. Over, we want the females only. So go to the females, we want the total number of females. So 9, 9, 3, 3. So that would be approximately, to 3 significant figures, that would be 0.248. So you have to understand, if you're given the symbols or given the probability statement, it's really easy to create your equation or your fraction because it's the intersection divided by your event A, or you're given that. However, on this next one, we're going to be using words instead. So it'd be easier to create this setup to make it look like this, so you can easily do our fraction. So we have material, so we're dealing with Americans recycle increasing amounts through municipal waste collection. The table shows the collection data for 2007. So we have material, which is paper, metal, glass, plastic, and other. We have recycled and not recycled. Notice that there are no totals on here, which is one thing that we do have to find. So you find the totals by adding each row up and then adding the columns. So the first row, the paper, is 83. The metal is 20.8. The glass is 13.6. The plastic is 30.7. The other is 68. Then the recycled is 79.4. And the not recycled is 136.7. So the total amount is 216.1. So now that we have all of our totals, we can go and find probabilities. It says, what is the probability that a sample of recycled waste is paper? So we want the paper. That's what we want. But it had to be of the recycled waste. So if you remember our denominator versus numerator from the sentences, the beginning part is always your denominator, and we want our numerator. But because it's not just talking about a randomly selected piece, we want of recycled waste. So if we want to write this out in a symbol like we do have up here, we would want P of. We want the paper, but it has to be from the recycled waste. It says probability that a sample of recycled waste. It has to come from that. So that has to be our given. So that means the paper has to come first. We want the paper given that it came from the recycled waste. So it came from recycled. So we'll figure that out in just a second. Let's go ahead and come down here and write out the same way we have it up here. What's the probability that a sample of recycled waste is glass? So we want glass, but it has to come from the recycled waste. So we want P of, we want the glass, but it has to come from recycled. And then we want, what is the probability that a sample of non-recycled waste is plastic? So again, we want the plastic, but it has to come from the non-recycled. So we have the probability of, we want plastic, but it has to come from the non-recycled. Non-recycled. I'm just going to abbreviate here. So now that we have this set up, we can find our fractions the same way we just did. So we know that together is our numerator. So paper and recycled. So P intersect recycled over, we know that given that has to be our denominator because we want it from the recycled. So the paper and recycled, we have to find the overlap. It's 45.2. Over, we want the recycled. So we want all of the recycled, 79.4. Three significant figures. That probability is 0.569. Do the same thing with the next one. We want the probability of the glass, that is glass given that it came from recycled. So we want glass intersect recycled over, we want it has to come from the recycled. So glass, find your glass, and the recycled is 3.2. Divided by, again, the entire recycled is 79.4. If we plug that in, 3 significant figures, that's roughly 0.0403. Again, 3 significant figures, the 4 is where you start your significant figures. And this last one, we want plastic, but given that it was non-recycled. So together, we want plastic and non-recycled, but given that it came from the non-recycled location. So we want plastic. So plastic, and then the non-recycled, where the overlap is 28.6. Over the non-recycled. So all of the non-recycled is 136.7. Or you could say 136 and 7/10. That's actually how it's pronounced. Plug this into our calculator to 3 significant figures. We get 0.209. So conditional probability, from the words, you have to make sure you understand what it has to come from. So if it had just said, what is the probability that a sample of glass is recycled? So it'll say sample of glass. That means that it has to come from the glass part. So that would be your denominator. It has to tell you what it's coming from. So this is the sample of it. If it just said, what's the sample of the waste? What is the probability that the sample of the waste was paper? So we would say of all of the waste was the paper. So it's very important that you understand what the words are saying and which values are coming from there. So sample of recycled waste, that's the whole thing it's coming from, all the recycled. This one's coming from all the recycled. This one's coming from all the non-recycled. So then we just find where they overlap. That is conditional probability.